Okay, so all questions on optimization that involve shapes, the basic idea is to apply your knowledge from previous grades on area, volume. Sometimes you might need your knowledge of functions or even geometry. So the questions on optimization, they come in different ways. Then we also have rates of change, which I'll show you later on after this example. Then the last aspect on optimization is calculus of motion, where you talk about equations of motion from physics and you apply calculus. So when you write your metric paper, you don't really know what type of a question on optimization is going to come. So you have to know all the different types of questions. So far, we have done mainly questions on 2D and 3D problems before you wrote your June examination. So today I'm going to carry on with this 2D problem, then I'll move on to rates of change, and then I'll also do calculus of motion. So in this question, you have to apply your knowledge from previous grades. Questions on optimization, they don't only involve calculus, but they involve the concepts that you were taught in previous grades. Right? So don't be scared if you see the diagram. It will require your knowledge from grade 8, grade 9, grade 10, or grade 11. The only time when you need to use calculus is when you are finding the derivative. That's all. Otherwise, when you create your expression that you find its derivative, you don't need calculus for that. And it's not grade 12 actually. So in this question, you are given a piece of wire which is 6 meters long, and it is cut into two pieces. Okay, so we've got a scenario like say, okay, let's say you've got a piece of wire like that. That's the piece of wire. Okay, it's 6 meters long. One piece is X meters long, which means you can cut the uh, the piece. Now, it's your choice here to choose whether you want X to be long, but 2 to be long, or you want the remainder 2 to be shorter, but you must use common sense. So one piece is X. The full length is 6 meters. Then it is cut into two pieces. The first piece is X meters long. So let's say maybe up to somewhere there, it's X. Okay? What would be the length from here? From here to there. If the full length is 6 meters, it will be 6 minus X. So this will be 6 minus X. Are you following that? Right. So one piece is X meters long, and then it is bent to form a square. So this X meters, it is then bent to form a what? A square. Right? And you know that a square has got what? Huh? Four sides that are what? Equal. So if you've got X meters, right? If I ask you, well, what would be the length of each side? Well, what would be your answer? The total length is X. That's the perimeter, remember? That's the perimeter as well. So what would be the length of each side? Because this piece which is X meters long, it is then bent to form a square. What would be the length of each side of that square? It will be X over 4. Remember, a square has got 4 sides. The total length is X. Alright? So it means each side is going to be X over 4. The reason why it's X over 4 is because if you add X over 4 times, you get what? X. Okay, this is a square, so it has to have sides that are what? That are equal. Right? Then the other piece is bent into a U shape. So the U shape now is going to be this one. This will be the U shape. Are you following that? So we have our square, we have our square, which is that, then the other piece is used to form a U shape. So that it forms a rectangle. So when you take the U shape, you fit it here. Right? You end up forming a what? A rectangle. Right? The rectangle is going to be BEFC, placed next to the square. It's shown in the diagram. So that's what you got. So the perimeter of the rectangle, excluding BC, is going to be 6 minus what? X. So this whole length, which is in red, which I put, maybe you say red or purple, whichever color you can consider it to be, that's 6 minus what? X. Are you following that? Then the question now says calculate the value of x for which the sum of the areas enclosed by the wire will be a maximum. Now, the fact that we've got this word maximum here, it means we have to find the derivative of an expression in terms of x. Then we equate that derivative to 0, we solve for x. Okay? But we are going to use what? The areas now. So we need to calculate the area of that of the sum of the two what? Of the two shapes. So we know that the area A, okay, since we have a square and a rectangle, right? I'm sure you can agree with me that the length of f of EF is also going to be x over what? 4. Do you agree with me then? Huh? And the length of FC is going to be equal to BE. Am I right? Those are opposite sides of a what? Of a rectangle. But check this now. If EF is x over 4, but the total length is 6 minus x, it means that we need to know what is the total length of CF plus BF. And then we add those two, we divide by 2 to get the length of CF or BE. Remember, this x over 4 is part of 6 minus x, because we know that from B here all the way up to C, the total length is 6 minus x. Are you following what I'm saying? So, first, I'm just going to write the general formula for calculating the areas of the two. The area of a square is going to be S squared plus the area of the rectangle is going to be LB. But the problem is, I don't know what is this B. Okay, the B, of course, I can consider it as x over 4. But the length now of the rectangle, I need to calculate that. So, the length of the rectangle, okay, is going to be equal to 6 minus x minus x over 4. Because we know that the length of EF is x over 4. That x over 4 is part of 6 minus x. So if you want to calculate the length of BE or CF, we have to subtract x over 4 from 6 minus x, then we divide by 2 the resulting answer to get the length. Right? So we divide this by 2. Now this will require knowledge of algebra. So this becomes 6. Now 6 minus x over 4 all over 2. But now we need to simplify it. We need to simplify it. So to simplify it, I'm sure you can see that our numerator, it has got a denominator here. So what will be the LCD of the numerator? to be a 4. So I have to multiply this 6 here by 4, this x here by 4, all over what? All over 4. Okay, so let me go to the next page. So on the next page, my length is going to be equal to, because if I multiply 4 by 6, I'll get 24. Okay, so that will be 24 minus 4x minus x. This is all over 2. Then I'll convert, so it's all over 4, right? Then I'll convert the division line, this division line, convert this division line to a division what? Sign. Remember I told you that it's always better when you're working with algebraic fractions to convert a division line to a division what? Sign. Okay. So then let's say times 2. This will be times 2. Sorry, divided by 2 over 1. Now I'm sure you can see that here we can now simplify minus 4x minus x. That will give us 24 minus 5x all over 4. Then you can introduce multiplication, then you can have that. You following that? Then, if we simplify this, we get 24 minus 5x all over 8. And we can simplify this further and write the numerators under the same denominator separately. So this will be 24 over 8 minus 5 over 8x. And this will give us 3 minus 5 over 8x. So this is our length in terms of x. Are you following what I'm doing here? So far, everything I've done here is not calculus. It's just knowledge of algebra, which is very important. Right? So I found our length in terms of x. Now, I'll go back to my diagram, and then I'm going to label my length now. I now know that my length is 3 minus 5 over 8x. Okay, let me use a different color there. So this will be 3 minus 5 over 8x. That's also 3 minus 5 over 8x. Okay? So now we can easily calculate the area of, the full shape. That is the sum of the square and the rectangle. Okay? So let's do that. So if you want to calculate the area, it's going to be s squared, which is x over 4 squared, plus LB. We know that L is 3 minus 5 over 8x times B, which is x over 4. Okay, so we simplify this, we get x squared over 16 plus, if I multiply that, I'll get 3 over 4x minus 5 over 32x squared. Then, what's the LCD? Well, we can find the derivative from here. Okay, let's find the derivative. So this is A. Okay, are you following that? Yeah, I have just simplified this x over 4 squared, it gives you x squared over 16. Then 3 minus 5 over x is the length, the rectangle, times x over 4. But I think it's better for us to just find a common denominator, isn't it? So let's find a common. So our LCD is going to be 32. Do you see that? So we multiply the x squared by 2, so that will be 2x squared. We can add that. Then here we multiply this 4 by 8, the 3 by 8, so get 24x over 32. Alright? Minus 5 over 32x squared. So this is all over 32. So it means our area in terms of x, if I simplify it to be 2x squared minus 5x squared, that will give you minus 3x squared. So it will be better to write this as 24x, 24x minus 2x minus 5x, that will give us minus 3x squared. And this obviously is over 32. But if I want to find the derivative, I have to write it separately under the same denominator. Right. So I have to write it separately under the same denominator. No. No. Yeah, so those two topics, starting with finance first, then we start. Okay. Right. Are you following?